When the James Webb Space Telescope launches from French Guiana, it'll mark the end of 25 years of painstaking work for thousands of scientists, engineers and technicians from 14 countries.
This has been the most difficult observatory NASA's ever done. It's taken over 25 years since our first serious conversations about it, and that's because we had to make something that was bigger than the Hubble, much colder than the Hubble, and had to be folded up for a launch. So aside from that, it's an easy project.
The $14 billion 6.2-tonne reflective telescope has 18 folding segments, each coated with a microscopically thin layer of gold just 700 atoms thick. Combined, the segments make a light-capturing surface 100 times more powerful than Hubble, capable of observing galaxies over 13 billion light-years away.
You see things as they were when light was sent to us, not as they are right now. And so if you can just look at things that are far enough away, you can see very far back in time. So you can see back pretty far if you look pretty far.
To capture these images, the James Webb Telescope needs two critical things: absolute cold and absolute darkness. Which is why after it leaves our atmosphere, it will start a 30-day journey to a special destination 1.5 million kilometres from Earth, called L2.
That's important because we can put a one-sided umbrella up there, and from the point of view of the telescope, the sun, the Earth, and the moon are all in one side. So you can hide behind the umbrella, and the telescope will get cold. So that's the only place that's close to Earth anywhere in the solar system we can go.
But the journey to L2 will be 30 days of anxiety and sleepless nights for the team back on Earth. The telescope must go through a series of 40 complex manoeuvres to unfold its massive mirror, extend its light collector, and deploy a 5-layer tennis court-sized shield to block the heat and light of the sun. There are 300 potential points of failure, and any one of them could end the mission.
I think we're expecting it to do it perfectly because we've rehearsed and checked everything, but we have to watch out that maybe it doesn't and be alert to do the right thing just in case.
When James Webb is finally in its orbit, it's hoped it will reveal important moments from our early universe, like how stars and galaxies formed and the mysterious time after the Big Bang.
It's been a fundamental question all my life. What's the origin of life? And if we can start to get at that, it would really be a huge scientifically important and I think possibly even culturally important discovery.
This is absolutely amazing. But if we can go and see into the past, can we also warn our former selves or our mothers not to cut a fringe when we're 7 years old? Is that a thing that we can do? Or?
I need photo evidence of that.
Oh, I'll show it to you.
Really?
It's horrendous.
I love these stories, but the thing that fascinates me is that this stuff makes total sense to a group of people. Because to me, it doesn't matter how many times...
That's not us as a
That's
group.
not us, but like, I know it's amazing, I know it's incredible, I'm so impressed, but you watch that scientist talk about it, it's like, this is just... You know, like he's running off a list for the shops. He lives and breathes it. But you really have to get your mind around the idea of going back in time.
Do you get how it works?
Yeah, I get how it works.
Go on.
Well, the light...
Don't do that.
What happens no time would be done.
What happens if it breaks, though? Like, they can't service it, obviously.
You just go to the local service station and it's a quick job.